Stick those two together. Okay, so what I was talking about, the Roman numerals, that's the stock system where sometimes we have to include the Roman numerals. And so you can look at all the ones on the chart that you have that have Roman numerals. The ones that don't have Roman numerals, they're usually in group 1 or 2. So if it's not in group 1 or 2, then there's a good chance it's going to have a Roman numeral. And I think you could probably go through. There are some exceptions to that, like zinc is +2, and it's not in the first 2 columns. That's kind of an exception to that. Aluminum is not in the first 2 columns. It's always +3. Silver is also not in the first 2 columns, and it's a +1. I think that's probably pretty much it. Now, this is the part that you're not taking a test on Tuesday, is the anions, the bottom half. So let's look at those at the bottom. Now, first of all, if it's an element with nothing else attached to it, it's just a, like for instance, if you go down on your chart, go to the go to the bottom half, column 1 or 1+, notice it says bromide, okay? It's a bromine, but it's not attached to anything else. A lot of the others, if you'll notice, they're usually attached to oxygen. This is a common one. And so bromine is in the second to last column. It needs 1 electron, so it'll be 1 negative. Yeah, tickle, tickle, tickle. So bromine is -1 or 1 negative, and when we name it, the monatomic ones, the single atom ones, we take the beginning of the name and then we change the ending, the INE. We're going to change the ending to an IDE. So if it's an anion and it's a single atom, we drop the ending of the name and we add the IDE to that. And so if you look at the second to last column, we have fluorine, chlorine, bromine, iodine, and astatine. Acetine's not on our charts. We'll just ignore that for now. And so the first one becomes fluoride, and then the next one becomes chloride, bromide, iodide. Iodide's probably the funniest one of all of them because it has so many vowels in a row. So iodide. Then we have some others up there like oxide and nitride and sulfide, or some others that they're not attached to any oxygens. When they have oxygens attached to them, then we have to have a special naming scheme. So Hannah asked a question, are there some patterns to this? I'm trying to show you what these patterns are to kind of learn these. And I would, it seems for most people, learn them by groups. Okay, like everything in this group has a +1, let's say. So that in the future you're thinking about, okay, in which group is it? Okay, then if I know it's in the first column, well, then I know it's going to be +1. Okay, so that's kind of the name. The other names that are on the bottom there, you notice that some of them have ATE, ATE on the ending, and some of them have ITE on the ending, and we'll have to explain to you how do we know which one's which, when we get to that point, right? We're not quite ready for that today. Okay, so now let's talk about a compound that's made up of two elements, and we're going to talk about, how do we name them and things like that. So binary, bi just means two, so it's going to be two elements. So like, for instance, water, H2O, is actually a binary compound. But we don't name it water is one of those that's been around for so long that we knew its common name before we knew its scientific name. And there's others that we know their scientific name, like CO2. We don't know it by any other name. It's just carbon dioxide. So in a binary ionic compound, the total positive charge has to equal the total negative charge. So when we're trying to write the formula for these, we're going to maybe have to add subscripts to make those charges be equal to 0. In other words, they add up so that the pluses and the minuses add up to each other. Now, as an aid, it says to determine the subscripts in the formula for ionic compounds, the positive and negative charges can be kind of crossed over. Now, let's use, and we need an example of this one to be able to practice. I'll just write down, I'll just go through the steps or the rules, and then we'll actually do it. Okay? So what you're going to do is you'll write down the cation first. Cations always write first, anions are always written second. And we're going to write the cation first, and then you'll write the, like this would be a cation. So I'd write down NH4+. Okay? Then I will, and in this, our example here is we're going to use aluminum. That's on your chart in the last column on the top where you have aluminum. So we have Al, and it's a +3 or a 3+, whichever you prefer. Okay, and then the other element is written after that, is 2+, or oxide. So if I look on my chart, oxide is in the middle on the bottom. See, oxide is O with a 2 negative. So a 2 negative or a -2, I'm going to write it that way, just the opposite of what's up there, so you can see it can go both ways. Okay, now, what subscripts need to go right here? Well, there's an easy way to do this, and then you sometimes have to do an extra step later on, maybe, but not always, is this number minus the sign goes here. This number minus the sign goes here. Now, is that correct? Okay? If I take 2 times a +3, I'm going to have a +6, right? And if I take 3 times a -2, I'm going to have a -6. What do those two add up to? Should add up to 0. That's what we want it to add up to. So if we've done it correctly, it should add up to 0. But the easy way is just kind of crossing over. But it's in math. Some of you remember in math, what am I looking for? If I have 2 and 3, like if I want to add 1/2 plus 1/3, I have to have a common denominator, right? Okay, so that's kind of what I'm doing here. Common denominator of 3 and 2 is 6. So I would like to have a +6 and a -6. How do I get +6 here? Well, I need to have 2 of those. How do I get a -6 up here? If each one's a -2, I need to have 3 of them to get to a -6. They have to add up to 0. The charges have to add up to 0 for these ionic compounds. Okay? And then, now if it turns out that both of these numbers, now like when you've done it, you realize they're both divisible by something, let's say. Let's say I had done it and I had come up with Al4O6, let's say. Okay? Well, remember, if it's an ionic compound, these subscripts are the lowest whole number ratio. They're the lowest whole numbers. is 4 and 6 the lowest whole numbers? No, both of those are divisible by 2, right? So if I take this one by 2, I get 2 here, and this one by 2, I get 3 here. So the real subscripts are AL203, even though I came up originally with AL4, let's say 06. I could have gotten them to balance out to be 0 with 4 and 6. It's just that my rules are for ionic compounds, these need to be in the lowest whole number ratio, okay? If they're, so that, sometimes you have to do that extra step. Now, when we crossed over, that was no problem. We didn't have to divide by anything. We know that 2 and 3 are the lowest already, okay? So that will be your formula then is going to be Al2O3. Now, the question always comes up about this time is, what about all this other stuff I've written? Do I need to erase it all? No. It's sort of like you did in math, you know, when you showed your work. You didn't erase, once you got your answer, you didn't erase all your work, did you? You know, you just, you know, that's just the work that it helped me to get to the right answer. So it's okay to show your work when you're trying to figure out how to balance the positive and negative charges. It's okay, no problem. So, even though you have the charges up here, that was part of my work to be able to figure out what subscripts needed to go right here. This +3 and this -2 aren't really part of the answer. They were just tools I used to get to the right answer. So like it says down here, the charges of the ions are not included in the final formula. You don't have to rewrite it again in my books. I don't see any value in doing that. Okay. Yes, it has all this work up here, but the actual equation is, or compound formula is Al2O3. That'll be it. Okay, now we have a way of naming our binary ionic compounds, the naming system. If you remember last year in biology, we talked about Carolus Linnaeus. He's the guy that came up with the scientific name for living things, and it was called binomial nomenclature. Nomenclature means naming system. Naming system. So we have a naming system for binary ionic compounds as well. And what we do is we just combine the names of the ions into the name of the compound. We name the cation first, we name the anion second. So like this one right here, Al2O3, how would I name it? Well, Al is aluminum and O is oxide. So this is, the name of it is just going to be aluminum oxide. Okay? That's all there's to the naming. I just name the ions. Just name the ions. I don't have to worry about these. I might sometimes have to put Roman numerals in if there's more than one possible charge.